morning. Today I'm going to explain about our project, which is sustainable solar powered ioT system for flood prediction and early warning. So first I would like to explain about our solar panel. Okay, the 30-watt solar panel captures sunlight and converts it into electric energy. The energy is used to charge the battery here. Okay, so here you can see the MPPT solar charge controller. What does the MPPT stand for? It's maximum power point tracking. Solar controller optimizes the solar panel's output, ensure maximum power is harvested from the panel. This also safely charges the 12-volt lead acid battery here, preventing overcharging or deep discharge. So for the lead acid battery here, it acts as a backup. It stores energy for times when the sunlight isn't insufficient, such as at night or during cloudy weathers. This ensures the system all year runs without interruption. Okay, we use the ultrasonic sensor here. The ultrasonic sensor itself gives 50%, contributes 50% to the flood probability. And here we have the water flow sensor. The water flow sensor contributes to the flood probability 20%. So here the rain module, it gives 30% of flood probability. So altogether 50, 20, 30, we can say 100% flood probability we can calculate from all these sensors. So now I will show you how it really works for the rain module, for studying of rain module. Okay, so first we will see weather condition of the rain module. It should show no rain and dry now. Yeah, there's no rain, dry. Now I will show you how first the light rain, how it works. You need to sprinkle little amount because it's so sensitive. So we see at the LCD whether it shows or not. Still dry, so we add more water. Oh, it's moderate already, so we should wipe a bit. Okay, now it's light. So I sprinkle more water, it would show now moderate by now. Okay, so I sprinkle some water more, so it should now it's showing moderate now. Wait, I'll show you this. Now moderate. So if I sprinkle more water now, it will show heavy rain. Wait. Yeah, now it's heavy. So totally, if it shows the water in the rain intensity heavy, by now it should contribute a 30% of flood probability, telling that there's 30% this place is going to be get flooded. So now we focus on the water flow sensor now. Now we are, for illustration purpose, we are showing the water is flowing very slowly. So the water flow, it's calculating the water, how speed it is show. So according to it, if it's full speed, it will provide 20%. If it's slow, it will provide 10% of flood probability to the system. So now we see the system. Okay. So as per the water is flowing very slowly, you can see the flood probability will reach in between 30 to 50. So if it reaches between 30 to 40, it means the water is flowing very slowly. So you can see it's 35%. So the water is flowing. We show that our water is flowing very slowly, and the flow rate is still 1.2, which shows us that the flow is also very slow. So for the next illustration purpose, we will increase the water flow to speed. Okay, as you can see, we increase the water flow. So as per now, it should have the water flow, the flood probability should have reached 50%. When the flood probability reach 50%, the yellow LED will light up, and it shows the flood probability 50%. As you can see, the yellow LED has started to blink, so it means the water has reached warning level. So the yellow LED is blinking now. Okay, so for now, we will continuously increase the water flow. So we're now waiting for the flood probability to 80%. So the red LED will be triggered and the buzzer will be triggered also in the pattern of SOS in Morse code. And we will receive our message in Telegram. So yeah, just reach 80%. That's why the LED is triggered and we're receiving our message. Look, the buzzer also has been triggered in the SOS Morse code. That's all. Thank you. Now, see this is the first data we received from the ESP32, which is flow sensors data. It shows the flow sensors pulse generated whenever there's water flows through the water flow sensor. It shows the water flow, how much high, how much faster and slower the water has passed through the flow sensor. So this is the rain code. Rain code refers to if it's there's no rain or it's dry. If it's dry, it will be 0. If there's light rain, there will be 1. If it's moderate, the rain code will be 2. If it's heavy rain, then the code will be 3. So to understand the raw data here, we have created this lah. No rain, light rain, moderate, and heavy rain. So that's totally 4 conditions. So this is the water level CM. Water level, it refers to the distance between distance between the ultrasonic sensor and the water water surface. So the basically what we use a bucket that is 32 cm height. So yeah, totally 230 cm. This is the difference distance between ultrasonic sensor and the surface of water. So field flow, it refers to the water level percentage. For we have used a calculation here where the bucket we use it as a height of 32 cm and the ultrasonic. So calculating from the ultrasonic to the surface of water, it will calculate how much water level percentage that has filled the bucket. So totally like 20, 40, 60%, 80% until it doesn't reach 100% exactly. It totally reach to 89% where the alert will be triggered when the percentage is higher. So this is pH value. From throughout the process, the pH value maintained 14, where 14 value pH value of 14 refers to alkaline. So the water quality here we have set to three stages, where 0 tells us the water is acidic, 1 is neutral, 2 is alkaline. This explains why the pH. This explains why the water quality maintained 2 because of the pH value also maintained 14. 14 means alkaline. So 2 is also alkaline, it maintained throughout the process too. So finally is the flood probability. You can see the flood probability 20, 40%, 60%, 80%. In this percentage, 80% where the alarm will be triggered throughout the process. So that's all. Thank you.